Sorry, just 1 second. Okay, are you guys seeing the slides? Awesome. Uh, Welcome. My name is William Cheung, and in case for all those that missed me last week, this week I'm here to follow up on another talk on state management and SPAs. Come on. Oh, crap. Sorry, just a second, just a second. Okay, there we go. Canva is an online visual communication platform that empowers the world to design. It's available through web browsers, plus iOS, Android, and desktop apps. At Canva, I work on the mobile experience team to help enhance the experience of our mobile users. Canva is a single-page app, and we use React to help us manage state and our choice of web application framework. So as an agenda today, we will cover at a high level of what state is, why you need to manage it, and what a single page application or SPA is. We will then talk about what React is, as well as cover some of its philosophies that it has. We'll then take a mini break, which may include pictures of dogs. And then finally, we will go over a few examples in code where we look at how React wants us to think about state. So let's get started. State management and SPAs. Before we can dive into state management, we need to ask ourselves, what is state? One definition would be the one on the screen now, in that state refers to the data or values that represent the current condition of an application or a component at a particular point in time. That definition is a little dry and academic. Another way I like to think about state is that it is a snapshot of data that can be fed into some sort of machine to recreate some sort of outcome. For example, I could write down a meal plan for today where I plan on having birch muesli for breakfast, smoked salmon for lunch, and fried chicken for dinner. This meal plan represents the state of our meals for today, and when I feed it into the machine known as my kitchen and pantry, then I can turn it into my meals for today. That's not actually what I had today. I wish I had fried chicken for dinner. Moving on. Now that we have an understanding of what state is, the next question is, why would we need to manage it? The reason is that it is much simpler. It's a much simpler way to program, and it allows us to program in a more declarative way. I.e., instead of describing what a thing is, rather than how to get there. Let's take a look at an example. So let's talk about addresses. On the left-hand side, we have a declarative approach of treating an address. And on the right-hand side, we have an imperative approach. For example, I could describe my address as 110 Kippax Street in Surrey Hills, New South Wales, and that would be a declarative approach. However, if I say, get off at Central Station, exit on the east side, cross the road until you reach the Woolies, till you reach the first left, then turn left for 350 meters, that would be a more imperative approach of describing the same thing. So in conclusion, a declarative approach is declaring what a thing is, whilst an imperative approach would be describing the steps to get there. And the reason why we tend to favor a more declarative style versus an imperative style is that it is usually simpler and easier to reason about. For example, just looking at the screen now, you can see that the declarative approach only takes up one line, whereas in the imperative approach, it takes up 5 lines. Now that we know what state is and why we need to manage it, the next question is, what is an SPA or a single page app? Well, according to Wikipedia, a single page app is a web application or website that interacts with the user by dynamically rewriting their current web page with new data from the web server instead of the default method of a web browser loading entirely new pages. Let's take a look at what that means in practice. So, in a traditional website, when a user makes an action that requires information from the backend, the web server sends back a whole new page containing this big bundle of HTML, JavaScript, and CSS, as well as the data embedded inside the HTML. And then whilst this is happening, the user goes through a full page reload. Let's take a look at how this works in practice. So if I could divert your attention to the left-hand side of the slide, a user fills in some form, maybe they're ordering, I don't know, dog biscuits or something, uh, in which it makes a post request to the server. Then, whilst they're waiting for the server to think about the request as well as generate the new page, they're looking at a full page reload, the browser spinner thingo, and then finally, when they receive this big bundle of HTML, JavaScript, and CSS, then the whole page is reloaded and they get the new page. Let's contrast this to what happens in a single page app. When a user makes an interaction with the web server, only the data that from the web server is sent back without a full page reload, leading to a much more seamless user experience. So let's repeat the exercise, but this time, if I could divert your attention to the right-hand side of the slide, let's say the same form. The user is ordering dog biscuits, and then they fill in the form for, I don't know, 50 kilograms of dog biscuits, and then they make the post request for that. And whilst they're waiting for the server to get back with the much smaller bundle of just the data to render, they usually only see a spinner for the bit which needs to reload. They may still be able to interact with other parts of the page. For example, filling in the 50 kilogram order for dog kibble. Uh, and then whilst they're waiting for that, the smaller bundle gets sent back. And then without the full page reload, they get back the new page. Now, and they don't get back the new page. They get back the new page with only the bit that needs to be re-rendered that is re-rendered. It can do this, single page apps can do this because all the elements of the web page are loaded up front in a single page app. Now, React is one such framework that allows you to build single-page apps. However, I should stress that it is far from the only one. We won't go into it here, but other popular examples include Vue, Solid, Angular, and many more. And each one of them has their own different philosophies on how a single-page app should be built. At this point in the talk, we have covered why we want a single page app, and this leads us to our next question, which is, what is React? What are the philosophies behind React? Now remember that each single page app has different philosophies on how to approach web development. And for React, they are JSX, virtual DOM diffing, component-based architecture, and unidirectional data flow. We'll go through them one by one. Let's start with JSX. When you open any React component, you are likely to see something that is returned that, when you open any React component, you're likely to see it return something that looks like this HTML thing on the right. So on the right-hand side, you can see that it is a React component called app, and it is a function that returns this HTML-esque thing, and this format, which looks like HTML, is this JSX, also known as JavaScript XML, but no one calls it that. So this isn't actually HTML. Underneath the hood, the React framework turns this JSX code into JavaScript calls that then creates the HTML elements. So even though it looks like HTML, it's not. It's JavaScript that creates HTML. Thinking about it as just HTML works for 90% of cases. However, it is the 10% that you need to be aware of. For example, if you can see here, it says class name equals app. Well, it says class name because class is a reserved word in JavaScript. So it needs to convert it from class name to the HTML class. Another React philosophy is its approach to know when and how to update the DOM. And it does this through a technique called virtual DOM diffing. However, to understand virtual DOM diffing, we need to first understand the DOM. The document object model, or DOM, is a programming interface for web documents. On the left-hand side, this time this isn't JSX, this is just HTML. On the left-hand side, we have a simple HTML document with a heading here in the body, H1, and a link in its body as well, the A tag that goes to link page, link text. On the right-hand side, we have the DOM representation of the same document. You can think about the DOM as the tree representation of a HTML document they can make changes to in JavaScript, and then those changes will be reflected with what you see on the page. So, for example, if you were to make a JavaScript call to change the text inside the H1 element, so currently let's say it's a heading, and we turn it into fluffy dogs. What you would do is you'll make the JavaScript call to change the element in the DOM here, and then after you update it, you'll see the new title being reflected on the screen. However, that was about the real DOM. And if we can manipulate the real DOM and see our changes on the screen, why would we need a virtual DOM? And what is diffing? Well, the thing is that DOM updates are immediate and they can be slow. Uh, if you use the DOM API to change an element's attributes, the browser will execute that immediately, and then it will need to do a whole bunch of subsequent downstream expensive calculations, like running the CSS engine, calculating the sizing, and then doing a whole bunch of pixel calculations. Like, for example, that title element might cause some overflow, and then we need to do overflow and all sorts of stuff. You would also need to, so DOM updates can be slow. We can't get around using them, but we want to make minimal and performant ways to update the real DOM. You would also need to keep track of what DOM updates you will need to make, and that can be error prone. And hence we want to make minimal and performant updates to the DOM. Let's take a look at an example. And let's assume that we wanted to update the title and also replace the link here in the A tag with a form. If we were to do that with the imperative DOM updates, we'll first update the title. And when we update the title, this is still a link tag. So it'll update the title, do all the calculations for the sizing, for the link tag and all that stuff. But we don't actually need to do that because we're going to replace it with a form anyway. So we're doing extra work here. And this is the type of stuff that React can help with. So React gives us a way to make minimal and performant updates to the DOM. And how does it do this? It does this with a technique called virtual DOM diffing. To break this down, let's split this into two parts, the virtual DOM and the diffing bit. So what is the virtual DOM? The virtual DOM is a memory-based representation of the real browser's DOM. So it's similar like a tree structure as well, but a much more cut down version than the real one. And the thing about the virtual DOM is that they are cheap to generate. They're just objects in memory. And importantly, updates to the virtual DOM do not get automatically reflected in the real DOM, hence the name virtual DOM. Now let's talk about diffing. And to discuss this, I'm going to be referring to the diagram on the page. So when a change is made to the React model, usually via changing state on a component, it causes a whole new virtual DOM to be created. Now remember that creating a virtual DOM is cheap and fast. Next, React goes through the process of diffing. That is, to detect what changes there are between the old DOM before the model change and the new DOM after the model change. In this case, the change has been highlighted in red. After React has detected what the diff is between the old tree and the new tree, it will then generate a minimal and performant operation to the real DOM. So here it's it's calculated the diff, and then from that diff, it's going to create a minimal update to the real DOM on the right-hand side. So to sum it up, React has virtual DOM diffing to abstract away the changes to the real DOM, and all of this is hidden behind when we're coding in React. We only need to care about keeping the model, the React model, up to date. And then we can trust React will do the right thing to keep our model and the real DOM in sync in a fast, correct, and performant way. Component-based architecture. React encourages its developers to write using a component-based architecture. It encourages developers to break down UIs into reusable components, making development more modular and maintainable. Combined with JSX, it is a really powerful tool to help you manage the complexity of your web app. So, for example, on the right-hand side, you can see that we have our app component from before, and it allows you to mentally equate what HTML is rendered through the JSX, as well as containing the complexities of other components. So for example, the counter component here is not HTML. It's actually another component, but when reading about the app component here, we don't need to care about the internals of the counter component. This architecture encourages you to write many small components to help you mentally deal with one thing at a time. Unidirectional data flow. React uses unidirectional data flow, that is, one-way data flow where data flows from parents to children, and never the other way around. And does this because it makes it much easier to track where data is and where it came from. Referring to the example before, we see that the number 3, oops, has been passed from app to children, from this app component to this counter component, as opposed to the other way around. And you can mentally think about it like the diagram on the right, where the data flows downwards from parents to children. And it's much simpler to think about things this way, because otherwise it can be hard to debug where data is, why it updated, and where it came from. So at this point in the talk, you might be wondering, why does any of this matter? And my answer to that question is that every framework makes choices for you, and it is important for you to understand what those choices are in order to write code that doesn't fight those choices. It is also important to understand that these web frameworks are all built on top of the fundamental web technologies of JavaScript, CSS, and HTML, and having a deeper understanding of how it all works will give you the tools to think your way out of challenging problems. Now it is time for a mini break of about a minute. During this time, I would encourage you to stand up, stretch your legs, and do what you need to while I tell you all about my dog's Halloween costumes over the years. So, Pixel is our 3-year-old Japanese Spitz, and every year we dress him up for Halloween. On the first year, we dressed him up as Darth Vader. It was like he might have been 1 or just before 1. And I don't think he quite knew what was happening here, so he's just looking confused. On the second year, we dressed him up as Harry Potter, along with the oversized glasses. We did manage to draw on his iconic scar, but that's okay. But the glasses really make the outfit. And then this year, we dressed him up in a witch's hat along with some bat wings. And you can't really see the bat wings in the photo, but this was a picture that they took of him when he was at daycare. Okay, welcome back. Uh, to recap what we have, whoops, to recap what we have gone through so far, we briefly discussed what state was and why we might want to build a single page app. We then dug deeper into the design principles behind the most popular web framework out there today, which is React. And now this section of the talk will focus more on the practical aspects of state management through examples. Let's consider the case where there is no state. There is only props. So the component, I'll explain what I mean by that. A component has no internal state. It only passes through, it only has props and it renders that straight onto the screen. So here on the right-hand side, you can see that the counter component's only logic is to render the attribute count that it got from its properties, or props for short. This type of component will always render what is passed in, and they are also known by several names. They're known as pure components, and although nowadays the lingo for this type of simple component that has no internal state is a presentation component, because it's usually solely focused on presentation. A convenient way to think about presentation components are as pure functions that take in props and renders some sort of HTML. And the important thing to note about presentation components is that they have no internal state and will always render the same thing given the same, will always render the same HTML output given the same HTML input, regardless of whether you render it one time or 1,000 times. However, what if we actually wanted to keep some state inside that component? In that case, it would no longer be a presentation component because it has internal state. But we want to do this because we want it to have some sort of value inside that is stable across different renders until it changes when we want it to change. Well, to understand that, we first need to talk about hooks, and in particular, the useState hook. This is the useState hook. Hooks in React are special types of functions that let you enhance your React components with things like state in this case. However, there are some rules with regard to hooks. And we can tell that useState is a React hook because it starts with the word use. So whenever you see use blah, chances are very good that it's a React hook. However, that also means that you need to be very careful with the naming of your own functions because that is only enforced by convention. And if you name your function starting with the word use and it's not a hook, then other readers will assume that your function is React hooked and be very confused when you use it and it doesn't do hook-like things. React hooks have two rules. The first is that you can only call a hook at the top level. And the second is to only call hooks from React functions. Let's take a look at some examples below. So if I could divert your attention to the middle component here, the counter component, this is a good usage of a React hook because it's called at the top level and a counter is a React function. It's a React component. By React function, I mean it can only be a React component or another hook. Now, in the bottom left, sorry, we have a bad usage of a hook. You can see that this use context hook is being called inside a conditional, violating the first rule of hooks, which is that they can only be called at the top level. So if your use X, whatever hook is indented somehow, then chances are very good that you're violating the first rule of hooks. And on the right-hand side, we have another bad usage of a hook because we're using a hook, but this function here it's not a React function. This is a click handler. So that violates the second rule of hooks, which is that they can only be called inside a React function. Now that we know a little bit more about the rule of hooks, let's take a closer look at the anatomy of the useState hook. The useState hook is a function that takes in an initial value and returns back a pair of references. The first being the value of the state and a set function that lets you update the state value. Let's see it in action. Now that we know how to store local state in our component, how might our counter look like? Well, it might look a bit like this. Here I have a counter which no longer takes its value from props, but instead it stores its value inside this component using the useState hook. So here you can see that we've set the initial value to 7. We return back the reference to the count, as well as a set function that lets you update the state. Using the set function, we've created 2 click handlers for our various buttons. I've called it inc, short for increment, to when called, will increase the current count to +1, and a dec, short for decrement, that will decrease the count by 1. And then here I'm rendering the value of the count inside the title. And I've set up 2 click handlers on 2 buttons, one with a minus, one with a plus, that will call these decrement or increment functions accordingly. And then it'll look something like this. And to prove that it actually works, let's go to a demo. So here inside the local state counter, we have all the code we just saw. And then when we press on the buttons, and voila, magic, the count increments and decrements. And yeah, it works. Let's move on. Local state works fine. However, what happens when you need to share state? And this is where React actually really shines. I think like one of the reasons why Facebook came up with React was because they encountered this problem where they had different components and they needed to share state and things were just not working well, which is how they came up with React. Uh, anyway, so for example, what if you wanted to build a counter here? As you can see with this per count, probably should have made this. This is much prettier. Anyway, what if you wanted to build this counter, but you also wanted a little badge at the top right that reflected what the current state was? Well, then you would need to do an exercise called lifting the state up. When we want to share state between components, we follow the following steps. Step 1 is to remove the state from the child components. We pass the hard-coded data from the common parent, and then finally, we add the state to the common parent. Let's take a look at what that looks like in practice. So this is on the left-hand side, we have the local state counter and that we went through before. And we want to remove all references to use state from it and replace it with values from props. Not only do we get the count from props, we also want to replace all our click handlers with values from our props as well, because they have references to the set function inside the useState. So they need to be passing from props as well. Now, you'll end up with something on the right-hand side here. You would notice that we have actually turned our counter component into a presentation component because remember, a presentation component is where the inputs, the output is solely determined by the inputs and it has no state. And this matches the definition of a presentation component. Next, for completeness, I'll also include the code for the little circle. So this is the mini count. All it does is it takes in the current count and turns it into a circle with a number inside. So we've done step 1. Now we need to do step 2, which is to pass hard-coded data from the common parent. However, in order to pass hard-coded data to the common parent, we need to first have a common parent. So here I've created a common parent to my 2 new newly created components, mini count and the prop counter with buttons. Note that I am passing in hard-coded data into both children. So here I've got the count, which is always going to be 7. And I've also got a click handler that doesn't do anything and another click handler that doesn't do anything, representing the inc and decrement functions. Oh, and I'm passing these straight into the count for the mini count and the prop counter with buttons. Now comes the final step, where we replace the hard-coded data with local states stored inside the common parent. So here I'm just turning the hard-coded data into invocations of the useState hook. We pass the count as props to the two children, and we also make the real click handlers and then pass those down to our counter to wire up the buttons. And after doing all that, you might end up with something that looks like this. I would like to call out that you can actually see React's unidirectional data flow in action here, where you can see the data being passed from the parent, which is a shared count, through to the child components, mini count and prop counter with buttons. Now let's take a look at the demo. So So here we can see the code for the shared count, and we can see the prop counter with buttons that we saw on the slide before. And we also have the mini count. And now you can see that when we press on these buttons, these two elements, these two counts are kept in sync because the data is stored in the parent and it's passed down. It's only stored in one place and it's being passed down accordingly to its children. And the whole thing works. To wrap things up, let's go over what we have covered today. We learnt about what state is and why we might want to code in a more declarative way. We learned about single-page apps and why we might want one. We then covered the most popular SPA framework out there today, which is React, in detail, and a few of its driving philosophies, such as JSX, virtual DOM diffing, component-based architecture, and unidirectional data flow. And then finally, we went through a concrete example where we saw state being managed through a counter, being created first with no state, then with local state, and then finally with shared state across multiple components. And thank you for listening to my talk. Are there any questions?